All right. Let me show you a couple things in the Schoology page so you know like what's going on. And then I won't take a whole lot of your time today. You'll have time to work on some stuff. On the right-hand side, you're going to see two things in the upcoming. One of the things is a lab, the Covalent and Ionic Properties lab. So there was a pre-lab that I gave you yesterday for you to do, and some of those questions also appear in the lab itself. And there's also this thing that says Ingredients Labels Project, and I'll tell you about each of those, and then I'll set you free so you know what to do. This is not due until next year, 2021, which probably can't be any worse than 2020 was. We're going to find out, I guess. So in the materials, in Unit 5, you'll find our current week. And in the current week are both of those things, the Ionic and Covalent Compounds Property Lab. So there's a link here that takes you to the video that you need. If you were to type this in manually, it's case sensitive. It's got to be capital B and capital L in Bond Lab, but it's a smart idea if you can open up another browser tab. And then whenever you go to this lab, so what it is basically the exact experiment that you would conduct if you were to do this live here in class. The audio is a little bit quiet, but so there are some different compounds that are described, and then there are chemical reactions that take place as a result of working with the individual compounds. So there's little videos and descriptions and observations that you can see. So these are not materials that you have in your house, and but it's good enough. It's as good as we can do virtually. So that's the link to see the video for the actual experiment itself. Whenever you click on the lab, the Covalent Ionic Properties Lab, it says Video Lab Properties of Ionic and Covalent Compounds. It's much like what we did earlier in the year with different properties of different compounds, except we were working mostly with like metals, metalloids, and nonmetals. This is a comparison of ionic compounds and covalent compounds. Sorry, I wasn't logged into my account here. Anyway, so in the lab, there's an introduction, and then there's some pre-lab questions. So what's an ionic bond? What's a covalent bond? Ionic compounds are typically composed of which kind of atoms, and covalent compounds are composed of which kind of atoms. The equipment that's used in the experiment is described, and then the materials are listed here. These materials, these chemicals, some of them you know how to name and write formulas for, like nickel 2 chloride and cobalt 2 chloride. You know about those, and sodium chloride. The sucrose, oxalic acid, and starch. You've probably heard of starch. Sucrose is the common name for table sugar, regular plain old table sugar. But oxalic acid you've probably never heard of, and that's okay. If you know that you can name the compound as ionic, then it's probably an ionic compound, like nickel 2 chloride, sodium chloride, cobalt 2 chloride. If it doesn't have a common name as if it's an ionic compound, then it's probably covalent. So the link for the video is right here. And then the description about the experiment is here. So normally you'd get the pie tin, you put some crystals in, but you're going to see the person who conducts the experiment do the exact same thing as the experiment itself happens. So whether or not something takes place, you can put that in the data table. So of the 6 compounds, there's chemical formulas listed here for the compounds that you don't know how to write formulas for yet. But for instance, sucrose, oxalic acid, and starch, the thing that each of them has in common are some carbon, hydrogen, and oxygen atoms. And you know that if the first element is a metal, it's ionic. In each of these 3 compounds, the first element listed is carbon, and carbon is a non-metal. So these must be covalent compounds. But you can write the formula for sodium chloride, cobalt 2 sulfate, nickel 2 chloride in the data table, the order in which they melt. In other words, which one melts first, which one melts second, which one melts third from the video Which ones don't melt at all? Which ones are soluble in water? Yes, if it's soluble, which means that it can dissolve in water, or no if it doesn't. And solution conductivity, whenever the compound is placed into water, so an important thing to know, water itself does not conduct electricity. Water is a non-metal, it is a non-conductor. In fact, normally we measure the purity of water by measuring its conductivity. Completely pure water is an insulator. It does not conduct electricity. It's one great myth about water. But when water becomes an electrolytic solution, in other words, when you put stuff into water that can make it conduct electricity, then solutions of water can be electrical conductors. So in this lab, the different compounds are placed into water, and then the demonstrator shows you whether or not it conducts electricity. Basically, if the light comes on in the conductivity tester, then the solution conducts electricity. And if it doesn't, then it doesn't. So whenever you hear the term an electrolyte, electrolytes are compounds that are placed into water that then makes water conduct electricity, but water normally does not conduct electricity. And there's post-lab questions. So which of the compounds are ionic, which are covalent, which have low and high melting points, which are better conductors? And then there's a chart here that shows melting point, solubility, and conductivity for some different unknown substances. And based upon their melting points, conductivity, and solubility, comparing that to the table you made, you should be able to classify them as ionic or covalent. And then as a review, there are some names or compounds, names or formulas for compounds, and you can tell whether they're ionic or covalent and either write their names or formulas. So for instance, there's a formula. You should be able to write the name. Same thing here. There's a formula, write the name. Here there's a name, you write the formula. Here there's a formula, you write the name. But based upon the name and the formula, you can tell whether it's ionic or covalent. So we can identify whether compounds are ionic or covalent by the name, by the formula, and then also by physical and chemical properties. So there are some things that are common and true about ionic compounds and covalent compounds. So this is a SharePoint document on OneDrive. Once you open this up and start editing it and stuff, it saves a copy automatically for yourself, and you can submit that. So that's what you want to work on the rest of the class today, and you can work on that anytime today or whatever. And the other thing is I'll let you loose here in just a minute so you can do that. The other thing is not due till after break, like Wednesday after break, but this ingredients labels project. So in your home, in your apartment, wherever you live, there are products that have labels on them. Cleaning products, kitchen products, foods, all kinds of stuff has labels. We have labeling requirements in our country that help people understand what is in different things. Many of the ingredients on labels, you won't be able to identify if they're ionic or covalent. In other words, you may see like a very long and complicated name with a bunch of numbers and commas and stuff in some kind of ingredient that's like in shampoo or something. That's not a thing that you could easily name or write formulas for. But you'll recognize, based upon the names and formulas of stuff we've talked about, certain compounds and compounds that have easy formulas to write. So like you might see calcium chloride or sodium sulfate, sulfur dioxide, stuff like that. Find 5 different compounds that you can write formulas for, from food products, cleaning products, toiletries. You'll find plenty. In fact, like you might get 5 just from 3 different products or 2 different products. This is not a SharePoint document. You download it, edit it, and then re-upload it, because there were some technical issues that students had in another class, because this was assigned in a different course like a little bit earlier. Anyway, so you get 2 compounds from a single product. You should have at least 3 different products. So they can't, all 5 of your compounds cannot be ionic or only covalent. You should have compounds that are ionic and compounds that are covalent. Not the common or organic name, but names like what we've talked about. with the common naming scheme, but you should be able to find them pretty easy. So what's the name of the compound? What product is it in? What's the chemical formula? Is it ionic or covalent? You can look up the melting point and the solubility, but you could also say either it has a high melting point or low melting point and whether it's soluble or not. A good clue is if it's like a cleaning product, if it's like if it's like Windex, well, Windex is a solution in water, so whatever's in there has got to be soluble in water. In a bottle of Windex, you don't see solid stuff sitting in the bottom. It's all in solution. So if it's a liquid, if it's a drink, it's gonna have to be in solution. It'd be disgusting if you had like a can of soda and then in the bottom there's a bunch of floaties or chunks of stuff. That's nasty. So yeah. Anyway, so that's the other project. That's a project to do over break. All the honors chemistry classes have been assigned that. So anyway, I'm not going to hold you anymore. That gives you time. You can do the ionic and covalent compound lab, this ionic and covalent properties lab. You can do that right now and get that done. If you need a little bit more time, you can work on it later today, or you have until tomorrow to get it done. But preview the stuff that's in yellow, watch the video, fill out the data. You should be able to get it done even like during this class period. That's all I have for you. I really hope that you have a relaxing, rejuvenating break. Spend time with family, but don't spend too much time with family you're not around much. Try to stay safe and stay healthy, and I don't know, hopefully you have a good break and we can all stay happy and healthy, and then when the spring semester comes, get that vaccine around, maybe get our counts down here and get back to school, see each other in person. So anyway, have a good break. See you in 2021. If you have questions, you can put them in the chat, or you can turn on your mic and ask them. But otherwise, I'll see you. You can go work on that lab.